this example, we are going to look at some quantitative data, and specifically the quantitative data that we are going to look at is discrete data. So these are countable values that were used to form this data set, and looking at this discrete data, we are going to organize it into a frequency distribution and then ultimately also make a histogram with it. So for this data set, it says the number of children per family is recorded for 64 families that were surveyed. Construct a frequency distribution. Now I have 64 values over here, and you can see that it's already been sorted. So we have a bunch of families that reported that they had 0 children. Quite a few families reported they have 1 children. And then we have the families that reported that they have 2 children, families that reported they have 3 children, then 4 children, 5 children, 6, 7, 8. And then out of the families that were surveyed, there was 1 family that they've reported they had 9 children. So you can see that we don't have a lot of different values in our data set. It spans from 0 to 9. And then also notice that each one of those values was counted. So every one of the families counted how many children they had. Each one of these values is going to become its own class. So each category of data is called a class. Now if we had really large data sets, we could actually group the data so each class contains an interval of numbers. Now that's not happening in this case. Because there's actually not a wide variety of different values here, we're going to group this so each class only has one value, specifically the number of children. So I'm going to go ahead and start making my distribution. So I have number of children, which is going to be one of my headings, and I'm going to make my table going horizontally as opposed to vertically because that's the space I have. So I'm going to be tracking number of children and then frequency. For the number of children, the data that I'm tracking, the values span between 0 to 9. So I'm going to start breaking this up. So 0, 1, 2, 3, 4, 5, 6, 7, oh, don't want to run out of room, 8, 9. Now for every one of those values, I'm going to go back into my data set and find out how many times that particular value occurred. So looking at the 0, 1, 2, 3, 4, 5, 6, 7, 8. So it occurred 8 times, so the frequency of the 0 is 8. 1 occurred, well that's going to be 8, and then 9, 10, 11. So 1 occurred 11 times. For 2, I'm going to have 8 right there, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Alright, so go ahead and continue in this manner. I would encourage you to pause this right now and work through finishing the values for the classes 3, 4, 5, 6, 7, 8, 9, and then see if the values that you get match up with the values that I'm about to find. Alright, so hopefully you paused it and you tried it on your own. So you should have gotten that the data value of 3 has a frequency of 11. The data value of 4 has a frequency of 6. 5 has a frequency of 4. 6 has a frequency of 2. 7 has a frequency of 1. 8 has a frequency of 2. And 9 has a frequency of 1. It's always a good idea after you make a frequency distribution. We were told that I have 64 values in my data set. So it would be a good idea to go through and just add up all of these frequencies and just make sure that they total what they're supposed to, which is 64, just so that way you didn't leave necessarily anybody out. All right, very good. So we have organized our data into classes. Each class only has the one value in it. Okay, so I have apparently 10 classes here. the first class had a value of 0, the second class had a value of 1, and so on. Okay. So then once we're done with that, we can make then a histogram. So a histogram is a graphical display where we're going to draw rectangles for each class of data, and the height of each rectangle is going to be the frequency of the class. We have to make sure the width of each rectangle is the same, and the rectangles will touch each other. This is a big feature of how a histogram is different than a bar graph, because the rectangles have to touch. We make histograms when we are dealing with the quantitative data. So when we have data that is numerical in value, we organize it into histograms, not into bar graphs, because that the horizontal axis is actually going to be a number line for the numbers in our data set. All right, so we've got our data set up there, and if you have a chance to have access to graph paper when you are making a histogram, that's always great because then it helps you with your spacing. If you don't, you might want to pull out a ruler to help you with it. Otherwise, you can kind of eyeball or freehand it, but the spacing does kind of matter. So be aware of that if you're just going to try to do it on kind of like a blank space. All right, so we're going to plan this out. Now, first off, I'm going to go ahead and immediately give my graph a title for what I'm going to be graphing here. We're going to be graphing the number of children per each family that's in the survey. Typically, the data set is going to go along this horizontal axis, so I'm going to go ahead and draw in a horizontal axis down here. Okay, and the data that I'm going to put down there is number of children. Let's try that again, spell this correctly, number of children, there we go. All right, so now my vertical axis over here, and this is where I'm going to have my frequency information. Okay, so it's always a good idea to label both of your axes. Sometimes it's assumed that people understand that these are your frequency counts, but I would say, hey, let's not assume, let's just go ahead and give people that information. Now down here for number of children, I have to have between our bars representing the values between 0 and 9. So the bar doesn't necessarily only need to be one box wide. You can make your bars more than one box if you're using graph paper like this, but it's consistent that what has to be true is all the bars have to be the same width. Now you also don't need to start like smack dab right against this axis. If you want, we can leave a little bit of space. I'm going to leave a little bit of space, and then I'm going to draw each of my bars to be 2 boxes wide. So that's going to be, I'm just going to plan this out first before I formalize everything. So this is going to be where I'm going to put my bar for 0, and then right next to it is going to be the bar for 1. Remember, there's no space in between the bars. So there's going to be my bar for 1, there's my bar for 2, for 3, 4, 5, 6, 7, 8, and then my bar for 9. Good, so I'm going to be able to fit all of that. So it's good to do that before I start drawing things out, because the last thing you want to do is realize you've run out of space. Now my bar for 0, if you look back up at your data set, needs to go up to 8, and then the bar for 1 needs to go up to 11. The highest bar needs to be up to 18. That is for my class of two children. So when I go to plan my frequency counts over here, I need to be able to get up to 18. So I can already see I can't count by 1 because I'm not going to have 18 tick marks that I can put along here. So I'm going to try to count by 2 and see if I can fit that. So this is going to be 2, 4, 6, 8, 10, 12, 14, 16, and 18. There we go. So I'm going to be able to fit that. All right, so now we can start putting down our bars. So my first class, which the data value is 0, has a frequency of 8. So I'm going to draw these lines up until I get to the 8. All right, so this is going to be for my first class. Now I like to put like this little cross hatches on those bars just to shade them in. And I'm going to go ahead and label the bar. Now when we label the bars and you only have one value in your class, we're going to label it with the value right smack dab in the center of the bar. All right, so let's talk through one more and then I'm going to give you a chance to finish this. So now let's do the class of 1. So coming back up here, the class that has 1 children had a frequency of 11. So I'm going to need to come over here. I'm going to need to estimate where 11 is because I only have tick marks at 10 and 12. So it's going to be about halfway between them. All right, so then I'm going to come down here. And then there's my bar for my 1 children. I'm going to go ahead and label the bar. And then again, I like to shade it in. So I'd encourage you to go ahead and work through the rest of this, kind of pause it and take your time building the rest of this. And then when you're done, go ahead and press play, and then we can talk through some of this to kind of summarize what we're seeing. All right, so hopefully you've gone through and you've finished this up. I'm just going to work through this really quickly. 2 goes up to 18. The bar for 3 goes up to 11 again. The bar for 4 will come up to 6 on the frequency. The bar for 5 comes up to 4. The bar for 6 comes up to 2. The bar for 7 only comes up to 1. The bar for 8 comes up to 2 again. And the bar for 9 only comes up to 1. All right, so I'm just going to put some shading on here. There is my finalized histogram. So a couple things to kind of point out when we're making these by hand, and this is also really a reason why we sometimes will let computers or technology do this for us. So your graphs, when everything's done, should have a title. You also should have axis labels on the vertical and horizontal axis, telling people what information is on there. When we only have the one value, okay, the class value is in the center of the bar. And we have consistent scales throughout. Now, what do I mean when I say consistent scales? Okay, so the spacing that we use needs to be consistent. So for instance, right here, if I made my bar 2 boxes wide, all of the other bars need to also be 2 boxes wide. Okay, I can't make one bar be like, for instance, wider or narrower than another bar. The other scale I have to pay attention to is my vertical scale. It's always a good idea to start vertical scales at 0. Okay, so the value that down here should be 0, and then if I'm going to put my first tick mark by counting my 2, that same distance needs to be represented a distance of 2 as I'm going up this axis as well. So I had to pay attention to my spacing both vertically and horizontally on my graph. All right, very cool. So we have taken our discrete data set and we have organized it into classes. And then from those classes, we have made a frequency distribution and a histogram. Now, we didn't have a lot of different values in our data set, so that's why we could organize them with one value in each class. We say that then it has a class width of 1. But what if we had lots and lots of different values? Or what if the data wasn't discrete, which means it could be counted, but it was continuous, which means we had to measure it? How does that affect the frequency distribution and the histogram? We will explore that next.